Hi there, this is John from RevSoft, and this video compares the functionality of trigger jobs between the centralized model and the distributed model that's in RevScheduler. If you have any questions at all, please feel free to email us at product_info@revsoft.com. To set up our test with the trigger jobs, we set up an initial job to run by time at 10:15 using system time. We then set up 10 jobs to be triggered based upon the normal completion of that time jobs. So example 2 trigger is a time job to run at 10:15 based on system time, as there are time zones in RevScheduler. And then the 10 trigger jobs to run by system time as well, 2400. Now, hang on a minute, 2400, I better explain something in RevScheduler. The clock, as we know, goes 23:59, then round to 00 for the minute and starts the seconds again. In RevScheduler, when you're defining a trigger job, you can set a lower limit, an upper limit, or boundaries for when it can receive dependency records and therefore the job can be executed. So between 8 p.m, 5 a.m. the next day, 6 a.m. to 6 p.m, it will accept dependency records and therefore execute during those times. 2400, it will accept and execute 24 hours a day. It doesn't matter when the dependency records are set. So we've set these no matter when this job is to be executed, because it could be forced to run at any time. And if we say update dependencies, yes, it will accept the dependencies because it's a 2400 job, which means it can run anytime, 24 hours a day. First, the centralized model. The initial time job would need to complete, then communicate the status back to the central server for the job completion, because don't forget, all the decisions are made on the central server. The central server would then process what is to happen next and then communicate back to the server it came from to execute each of the 10 trigger jobs. So we did some timing estimates. We estimate, first of all, completion, go back, decide what is next to do, send it back to the server, then send back 10 requests to say, okay, run this job, run this job, run this job. So, sequence, send the completion, process what's to happen, send the action. So we estimated 1 second, 1 second, then 1 second for each of these, and then an extra half a second for each of the 10 jobs to receive the request from the central server and submit the job. So all up, we figure it's about 17 seconds. And we're being pretty kind to it based on that. Okay, so 17 seconds. Can the distributed model come in under that time? Well, the short answer to that is yes. By how much? By a lot. Let me show you. This is our smallest IBM iSeries server. It's got a smart agent, local database. The job actually ran. The first job example, the trigger, completed at 10:15:16. And one of the things up here is accuracy, VASE, visibility, accuracy, speed, and efficiency. All the timings in RevScheduler on every platform are down to microseconds, millions of seconds, because accuracy is important. So we completed in the 10:15:16 second, and then 10:15 second, the last job was submitted in under 1 second of the first job completing. So what we've got there is we've got all the timings. The figures do not lie. So what we've got there is we've got all the figures there that the actual gap was 0.95 of a second. So quicker than this job completion could get back to the centralized server. We've already submitted the 10th job and we're up and running. This is the power of a distributed processing environment where the smart agent makes the decisions locally. Here's 2 IBM iSeries servers with the jobs that ran today, 28th of March. They're small PO5s, they're tiny IBM iSeries. Again, 10:15:15 6358 is the completion of the example to trigger. They've all been run by the engine, they haven't been forced to run. The 10th job is submitted at 10:15:16.61. So again, under 1 second from the completion of the time job to the submission of the 10th trigger job. You can actually see all the timings there. And don't forget, when we're talking about scheduling, VASE, visibility, accuracy, speed, and efficiency. Here is the accuracy part. All timings on all RevScheduler processes are down to microseconds, millions of seconds, because we're running on some extremely fast servers. Here's another small PO5 server. This time it only triggers 5 jobs. Again, run by the engine, due to run at 6:15. 6:15, 15, 4, 9, 5, 6. Again, the 5th job has been submitted at 6:15, 16, 004. Again, under half a second. So what we're talking about here is speed, because the smart agent on each of the servers is making the decision locally, not having to send back to a central server or a central point of failure for what do I do next. All the decisions are made locally. Every server that has RevScheduler on there can make the decisions about dependencies, trigger jobs, etc. It's much more powerful. Okay, the tail of the tape, side by side, centralized model, distributed model. Again, these are only our estimates of the information going backwards and forwards, but we think we've been pretty kind, especially if this server is in cloud and this is on premises. So we've been pretty kind. We still think it's 17 seconds, but with the distributed model, it's over 1,750% faster. This is speed and efficiency. So if we've got 3 servers running scheduled jobs in the centralized model, you now have a 4th server, because these guys will run the jobs, but all the decision making will be done here. So there'll be a lot of communications backwards and forwards, letting you know. In the distributed model, if we've got 3 where they're all got local databases and smart agents, these could be 3 IBM iSeries, because DB2 is part of the firmware. Again, it could be Windows, Linux, Unix, ZOS, whatever you'd like. You could share a database between the 3 servers. It's entirely up to you. But even though you would share the database, all the decisions about what is to happen next is made on each of these individual servers. So you go from having 1 decision maker here to 3 decision makers running in this type of scenario with RevScheduler and distributed model. Well, that's it for the trigger jobs. If you have any questions, please feel free to email us at product_info@revsoft.com. Please check out the videos on the website about the distributed model or any other things. And don't forget to check out the Learning Center if you're interested in more of the things that are happening in RevScheduler. Thank you very much for your time. Have a great day.